Good afternoon, everyone. Thanks for joining us over your lunchtime if you're on the East Coast. Today, we're going to be talking to you about Nightingale and some really neat ways you can use artificial intelligence and machine learning to turbocharge some of the analysis you're doing. So today, you are going to hear from myself and Wei. We're from CVP's Data Science and Engineering practice, and we've got a few cool use cases we're going to show you. Before we get started, just some quick info. So we're going to be using our platform called Nightingale today to run most of these analyses. It has a lot of pre-built features in there, like to let you do machine learning and explainable AI to really quickly find the insights that you're looking for and surface them faster. It's all built in a very secure fashion. Each customer gets their own distinct Nightingale enclave, and it's built with a lot of components for make it secure for federal customers, especially using things called a program called FedRAMP. It's open. We've got a lot of open data access and different ways you can get information. We'll talk about that a little bit more. And then it works with a lot of other things. We have some recommended tools in here that are great, but you can always bring your own tools. This isn't intended to be a closed ecosystem. And it's all named after Florence Nightingale, who you may have heard of. I knew of her, one of the founders of modern nursing, but what I didn't know before we started all this was she was also one of the first citizen data scientists. Collected a lot of information while she was caring for patients, and she also came up with her own visualization, which in the 21st century, not so exciting, but this was 200 years ago or so that she did it. It's pretty cool. You can look it up afterwards if you've got a chance. So we've got 3 demos we're going to show you, showing all different sort of topics. We're going to be doing these on Nightingale. At a conceptual level, Nightingale is everything you see in the blue box here. So we've got an unlimited capacity data lake, which is still fantastic to me because I remember the days where you had to negotiate for how much data you were going to store. Now, within reason, we can store unstructured, structured, raw, transformed data for 2 or 3 cents a gigabyte a month. All of this data can be queried by the scalable query engine, which runs industry standard SQL and can query all different sorts of files, and any tool that supports JDBC or ODBC can connect to it. So you can use a lot of different BI tools. From the query engine, we've got 2 different ways you can get at the information. So the first one, the shared analytics workspace up here, this uses fairly industry standard Jupyter notebooks for data scientists who want to run their analyses as code and do all sorts of different things. But also for folks who want a little bit easier experience, want to make ad hoc dashboards or reports, you can come in through the dashboard or report interface. They both point at the same set of data. You can use one to create data for the other, and they interoperate nice. And then ultimately, you can provide your analyses as all sorts of different options. So last slide before we get into some of the demos here. What you may be used to are systems more like this first column, the today. What we're looking for and what I'm really excited, this is kind of the system that I wish I had a couple of years ago, was with Nightingale, you can get all this neat AI and visualizations. It's all very easy to manage. We call it a managed platform as a service because we take care of running it all for you. The data is all accessible from various tools. It's not locked up in silos, and the software has been tested up to querying 300 petabytes of information. So you're not going to run out of headroom for any sort of information you want to manage. And most importantly, and what a big theme we're going to hit on today is the platform is data agnostic, but it's really good at helping you find and surface insights in your data quickly by using a property of machine learning where it finds things about the systems going on. So you can have a big haystack and it's going to help you locate the needles in that haystack without being told really a lot of information. So demo number 1, we're going to look into a data set that actually came from the Census Bureau and see if we can automatically figure out what seem to be some factors that are associated with income inequality or people being high or low income, or predicted to be high or low income. And it's going to be pretty straightforward. The steps we're going to run through are we're going to get the data. We're just going to download it. It's in a file. We're going to do a little bit of cleanup just to make it a little easier to understand. Then we're going to automatically build 14 different ML models, and you'll see this. It's really like one line of code, and it kicks off creating all these different models. We're going to choose the one that worked best, and then we're going to ask the system to explain what the ML model found in very easy to understand infographics, visualizations that show us what we're there, and we'll explain how to interpret them. So I'm going to flip over to, I've already got the Nightingale environment up here, and I'm up at the top. So you can see we download some data, and I'd ran this before, so it's actually already there. It's just in a CSV file, which you can, if you haven't heard of before, is kind of a simplified spreadsheet. This table right here is just a preview of what was in the file. So it had 32,000 rows and 15 columns. Each row here is basically a person. They're technically statistical representations of a person. That's what this final weight column is. So some of them represent more than one person, but we're going to think of them as people. And then for each person, we know what type of work they do, what sort of education they had, how many years of education, their marital status, some demographic information, some tax information, how much they work. And then this target variable, this is actually their bucketed income. Were they below or equal to 50K in annual income or above 50K? And you can see there's people that fall into both categories. And we're basically going to tell the ML model to predict from all of these what this is likely to happen for an arbitrary person that it hasn't seen yet. So we have to do a few tweaks to the data. You can see we just take this less than or equal to 50K, make it a 0, greater than 50K, make it a 1. That's really to make it easier to read on a chart. We create something called dummy variables, which are just a way of taking a multi-level categorical variable, like what sort of work do you do? Do you work for the federal government, local government, never worked, and spin it and give us 1 or 0 flags for each specific possible value there. And that again is really just done to make it a little easier to read the charts later on. We turn on the AutoML environment using this cool library called PyCaret, which we've already got installed here. And this tells you a lot of diagnostic information just about the environment starting up. I could spend 10 minutes talking about this, but it's all useful information for a data scientist to see what's going on and what sort of automated checks or cleanups are going to be done. You can see this one little command here. We basically tell it to start up and try all these different sort of ML algorithms. You may have heard of some of these. If you're interested in them, you can look them up on Wikipedia. They're all pretty common ones. And it tries all of these different algorithms against the target variable, that one that we said was below 50K or above 50K, and tells us which one did better. And you can see most of them do pretty well. These two didn't do so great, but a lot of these boosted decision tree ones did well. Cat boost edged out by a hair here, so we're going to do check that out as well as the second place finisher. This does a little bit of hyperparameter optimization and checks out how the model's doing, and then we can start seeing some visualizations like the area under the curve that helps us see how well the model's doing. I'm not going to dwell on this too much. These are diagnostic tools that data scientists uses to see how the model's doing. This is a different one. What I really want to focus on for the next minute or two here is some really real world useful things. So this feature importance plot, this has been around for a while, but it's neat to look at. It's basically telling us a first pass look at what factors in our data set were found to be important in predicting that target variable. So surprise, surprise, age was found to be most important. It's not really telling us positive or negative, just ones were found to be important in the outcome. So this is kind of interesting to look at to confirm some, probably common knowledge that older people with more experience on average tend to make a little bit more money than younger people. This is a plot that tells us how well the model did in predicting the two different outcomes. What I really wanted to get to was this picture, which is called a SHAP plot. And It's an open source library that we've integrated and a lot of organizations actually use. Each dot on this, you can think of representing a person. Each row is an attribute of that person. The more red the dot is, the higher that attribute is numerically. So the bigger, numerically. The more blue it is, the lower it is. And if you remember, a lot of these categorical variables, when we did that get dummies thing, sometimes also known as one-hot encoding, we converted them to zeros or ones. So for something like married spouse, if it's red, it just means you are married. And if it's blue, it means you're not married. So one of the most important factors it found in predicting high or low income was whether or not you were married. Not too surprising. Age again showed up here, and this transition from blue to purple, because this is a true numeric variable, people can be all different ages. It's basically telling us, on average, very young people are predicted to have lower income. As you start moving to the right here, as you get older, on average, again, you tend to have higher income, though you can see some purple and there's a couple reds in here. It's not a foregone conclusion. What was really interesting to me, and if you were watching, none of the code in here did we ever tell the model anything really about how, what is income, what are capital gains, what is age. It figured out that there's this attribute called capital gains that has a distinct nonlinear relationship with income. So all these red dots, these are people who had higher capital gains, but you can see there's this big bulge. There's all these people right here that have low or no capital gains, honestly, and it's slightly to the left. And what the model figured out, which in hindsight maybe makes sense, but I didn't think of it as first, people with lower income tend to not be able to accumulate lots of financial assets, which are how you get capital gains or losses. So low income people, a proxy way of knowing that they're likely low income is they had zero capital gains. They didn't have any assets that they could either, that they had to pay tax on, or the invert the capital loss. But this was actually a really good predictor of being low income, the fact that someone had zero capital gains. You can see there were some lower income people that higher, but all this over here, except maybe like one blue or purplish spot right here, all the higher income folks all tended to have high value for capital gains. There's a couple other intuitive ones in here. The more you work, you tend to have more income. We could spend a lot of time talking about all these, but it's that's the whole point. With very little work, it told us all these things about our data set, and we didn't have to have a lot of domain knowledge about how income and taxation works and all that. So with that, I'm going to turn it over to Wei, who's actually going to go through a more detailed example.
Thanks, Cal. Hi, my name is Wei, and today I'm showing you our second use case on CVP's data analytics platform, Nightingale. But using Nightingale, you can empower the data analyst to iterate quickly, even when your data set is really, really big. I'm about to share my screen now. Okay. So this is the first page that users see when they log in, and you can see how we have different modules here. We have the data science notebooks, and we also have a business intelligence dashboard. What we're going to do here is we will look at the same data sets using both the data science notebook and the business intelligence dashboard. So the data science notebook here. What you see here is what you're seeing now is a Jupyter Notebook. The Jupyter Notebook is an open source web application that allows you to create and share documents that contains live code, equations, visualizations, and narrative text. So most data scientists in your organization likely will be familiar with a Jupyter Notebook. And what's nice about Jupyter Notebook is that it's data agnostic, and therefore so is Nightingale. We are right now going to demo using transportation data, but we also have clients that analyze healthcare data, business data, and business data. But also Nightingale can analyze both structured and unstructured text in all industries just by using this interface. This demo is about big data analysis and how Nightingale can empower us to analyze a lot of data. And this used to be a problem because analyzing big data used to be a constraint when organizations had these legacy systems. It would take forever to load data, to get the results from the queries. And the data analysis I'm about to show is here. It's not something that you want to open up in an Excel spreadsheet or something that you want to open up straight from a Tableau desktop, because chances are it's not going to run. You won't be able to view the data. And even if the query were to run, it probably would have taken hours. So on this analysis, we're going to show you how we can load and analyze 100 million rows without having to spend hours waiting for the queries to run. The way we're going to do it is we're going to see how our distributed SQL query engines can make iterative data analysis possible. We no longer have to wait for hours to see each results. And on Nightingale, we can expect response time ranging from sub-seconds to minutes instead of hours, even with 100 million rows. And how big are 100 million records? If you look through a record every second and you don't sleep, you don't stop, it will take over 3 years nonstop counting just to go through each record. Like, it's a lot. So now here, we're going to look at the data. The data here that we're using in this demo comes from New York City Taxi and Limousine Commission. They published these trip data about the taxi trips that's happening in New York City. And we pulled 18 months of data that got it to get us about 100 million individual records. So what I'm going to do next is I'm going to scroll through this Jupyter Notebook in order to kind of see how I kind of built the analysis. What I did first here is I loaded the relevant libraries and I loaded all these CSVs. They came in by month. And I quickly defined the column names and the column types. And then what I did next is I want to see kind of how quick it is to see how many rows I have loaded in this data set. Here you can see how it took only 2.02 seconds for me to count how many rows there are in this data set. And next, I want to do something slightly more complicated. Just looking at summary statistics is always very helpful when you're first trying to do explorations and to get more familiar with the data. So what I did here is I wrote a SQL statement that says, he grouped by month. I want to see how many trips there are in each month. So I wrote the SQL queries and I got the results. And you can see how it took only 30.1 seconds for me to get the results of this query. And this is really nice because when you're in the exploratory phase, oftentimes you don't really know where you're going and you kind of just take it one step at a time. And it's very important that each step takes only a little bit of time. Otherwise, you're kind of stuck, and it's also very disruptive building kind of an analysis when you have to wait for a long time to get the query results. Some of us are more visual than the others. So given that we Nightingale empowers you to have access to open source libraries, what I'm doing next is I pulled in a visualization libraries, and with basically like 2 lines of codes, I was able to quickly build a graph to show me the trip by month data. And here we can see how the trips count has dropped in March and in the spring of 2020 because of COVID, because of quarantine, and also because the pandemic has changed the reporting requirements at the TLC. And it's it's a huge decrease. This is very nice because a lot of times when we just look at the data, it will take a while for us to get to the insights that we're looking for. But with a graphic, it it'll take 1 second. You can definitely see that the trend has changed dramatically in the spring of 2020. It's pretty good, huh? So we just went through this analysis. It's pretty straightforward, but we did have to code. And coding is powerful for people who can do it, but we also want to make sure that people and the stakeholders in the organizations who are not comfortable with Python or R can still interact with the data and find the insights that they need. Next, I'm going to show a drag and drop dashboard that were designed to empower these specific users who prefer a more intuitive user interface rather than a programming interface. So here is the high-level architecture diagram that Cal showed earlier. What we just saw is we were able to pull from the left to the right. We were able to see external data from external sources. We pulled it into the data lake, and we leverage our scalable query engines and then build intent analysis in the shared analytics workspace. The notebook that I just showed is something that you can easily share with people in your organizations with proper access permissions. What we're going to do next is, again, starting from the left, external sources, then to the unlimited data capacity, going into this query engines, but instead of going to the shared analytics workspace, I'm actually going to go access the data using the interactive dashboards and reports. So here we're looking at a dashboard using the same taxi trip data. You can build graphs, summary, see the trips. You can see how in this dashboard, the number of the first graph with the pink line chart, you can see the number of trips per day have declined in March of 2020. We can see summary statistics, the average trip distance, how much on average it costs, the number of taxi rides in our data sets, average passenger count. And this is really nice how you can build different kind of graphics, different color, different chart type. And I'm scrolling down. What we can see here, I definitely want to kind of showcase the bottom right where we see a map. So this dashboard is also, you can also build a map into your dashboard. And maps always tell the story better, especially when the data set is location related. The map chart that we see here now shows the top pickup zones for trips to JFK. What I did here is I query for all the trips to JFK, and I say I want to group them by where the trip started. So the darkest one here is the theater district. What this graph tells us is that the most popular origin pickup zones for trips to JFK is from theater district, followed by Midtown Center and Midtown East. So most of these trips are going from the Midtown area of Manhattan. And here I can also add notes, which is always helpful because to include relevant links, etc. What's really nice about this dashboard is that it took me less than two hours to build this dashboard. Here I can show you. Here I click editing, edit this dashboard, and I can move these numbers around. I want to make them smaller. I can change these charts, make them smaller, bigger. And it's easy how I can kind of like change colors or even the chart type. It's pretty intuitive, and that means like even your business analysts who are not data scientists can build a report using this dashboard and have access to the data. So here I have a user diagram, like I say that Nightingale is designed to serve both whether it's business owners, data scientists, or data analysts. I'm just gonna give everyone a few seconds to read this chart really quickly before I start explaining it more. Okay, so specifically, I want to highlight the last one, which is the executive dashboards. With any data system, our goal is to kind of uncover the insights from the data and trying to understand how we can use these data to make business decisions. And the executive dashboards that we just saw, especially important to the business owners and the data analysts. Next, I want to show you our third demo. It's a use case about how we can, being able to access powerful machine learning libraries via Nightingale can help us get to business decisions much sooner. Here, I have a weblog file. So in this demo, the scenario is that your business owners wants to assess if there are any unusual events in the network traffic. Are there any suspicious activities from users that are viewing our site or access our servers? Well, let's find out. Here, again, on the Nightingale architecture diagram, what we're doing here is we're pulling data from an internal source. We're putting it into the data lake. We leverage our query engine as well as our shared analytics workspace that has access to open source libraries in order to get to our insights. Okay, so I'm going to scroll down and kind of walk us through the analysis. Here, I first ingest, kind of import the relevant libraries, and I pull in the data source. Here, data set, we can see how for each log, we can see what the IP, and also the date that the log event happened and the actual log. So then I clean up the data. And then the next is I want to use an extended isolation forest for anomaly detection. You can see how with one line of code, I was able to initiate an extended isolation random forest model. And then another line of code, I was able to compute the path, and boom, 12.3 seconds, I'm able to build an unsupervised machine learning model on these network traffic. So let's scroll down and look at the results. Here, the first one is are the normal log entries. We can see how these are from IP addresses. They are downloading different likely like image files. So they're just viewing our websites. And let's look at things that are more strange. The top 5 anomalous log entries here, we can see how 4 of them actually from the same IP, and the log events included SSH. So what is SSH? SSH is called a secure shell. It's a network protocol for one computer to connect and control another computer. It's useful for you to log in like remotely, but it's pretty bad if it's an unknown computer trying to take control of your server. So what's really nice here is, again, we're trying to look for the needles in the haystack. We didn't know what the needles were going to look like, the size, the shape. But with unsupervised machine learning models, we were able to say, hi, these few events look very strange and they're very different from the rest of the log events. So this is pretty nice, but it's also a bit abstract. And what I want to do is I want to pull in more libraries, such as kind of the scikit-learn, the machine learning libraries, to help me to map this data onto a 2D plane. And then I can use another visualization library to draw the distribution of these log events out. I'm going to scroll down. You can see how I pull in scikit-learn. I use a principal component analysis, map everything onto a 2D plane. Then I imported alt-air as a visualization libraries. And here, like it's a pretty nice chart. What I did here is just in a few lines of code, I was able to build to kind of map all these log events on a 2D plane. you can see the orange circles, they represent all the normal log events. And the green ones are the SSH events that are pretty far away from the other clusters. So that's it. A few line codes, a straightforward analysis on a popular user interface that most data scientists are very familiar with. And we can use the latest machine learning libraries and have the smart people to help us to surface the unusual events in our network traffic.
Yeah,
Cal,
that was
back
good.
to you.
Thanks. Yeah, that was really cool. It occurred to me in both cases, you ended yours with a graphic that, like you said, kind of made it really easy to see what was going on. And
Yeah.
I know from, I'm sure many people have been on projects in the past where you were like generating the chart manually in Excel, and every week it took like an hour to update it. So it's neat
Yeah.
that the code makes the chart, because, obviously there's a lot of work to get there, but in the end, it was really out in about a second. You could spot where COVID caused all the taxi rides to fall off, or it was really obvious where all those green dots were clearly separated from the other ones, from the orange ones, even though, we didn't, you didn't have to know that they were anomalies to see that there's something funny about that. Cool.
Yeah, it's always nice to tell the story of the analysis with charts.
Yeah, yeah. I see from the time we are ahead of schedule, so we actually have a bonus demo that we had ready in case we do have some extra time. So I'm going to go back to screen sharing. And there's Billy Mays to help us out. So if you've checked out our website before, you actually see we have another platform as a service that we offer called Hopper, which is kind of like an automated software factory in a box. As Nightingale helps data scientists be really efficient, Hopper helps software developers build applications really quickly. And part of making that all efficient is having good data. And we have lots of data from the software development process as part of Hopper, including what the code for the application is in the version control system, as well as bugs, problems that people found, and then put into the issue tracker for the applications that they're developing. So one of the AI bots that we offer with Hopper, actually given a new bug report, recommends to the software developer where they should go look as the likely place where the problem resides. And we built this bot and the other ones using Nightingale, and we thought it'd be interesting to show kind of a simplified version of it and how you could make your own similar sort of bot for maybe a similar problem or even a totally different type of problem using the same sort of technology that we did in Hopper. So I'm going to go back to our analytics environment here, and you can see we have this file called bugs.csv. This is just a flat file we had that we exported and anonymized a little bit, but this is exactly the same information that we pull from Hopper via APIs, just in a file format. So you can see we pull it in. We've got about 416 entries in here. Each record basically represents a problem, who fixed it. So these are some of our employees, and then what the text of the actual problem was, and you'll see these in more detail, and then the code where the problem was fixed. And the idea is we could look at the code or the description of a new problem and say, they're complaining about error 5. You know what? I bet that's over here. Instead of having to look through the, all the different files that make up the application, why don't you go check here for the problem? So we're doing a multi-class classification problem on unstructured text would be kind of the technical way of describing it. We pull in the data, we drop some columns that we don't need, like the unique ID of the bug report. We don't want the model overfitting. And then we run it through this neat class of neural networks called transformers, which can actually do a whole bunch of different things. The specific one we're going to use is called Roberta, which is a enhanced version of a more famous one called BERT, B-E-R-T, that Google made, and then some folks from Facebook realized they could optimize it further into Roberta. But there's lots of other versions of these types of transformer models out there. and they have this really neat property where you can pass them strings of text. And because they've been trained on substantially millions of sentences, they understand synonyms and semantics, and you can give them a string of text and it will develop a numerical representation of what that means. So they move from natural language processing to, some people call this natural language understanding. So Roberta can give you this numerical representation of a sentence, and similar sentences in English will have similar numeric representations. So you can start to develop this very deep automated understanding of what people are talking about. So we basically take all of the bug reports and we run them through Berta, and we get this structured set of numbers. So I'm going to scroll down a little bit. You'll see some warning messages from the model starting up. But fundamentally, what we're doing is we're taking in each of our entries. So like, here's one of the bug reports where someone's saying, I did this, here's what's happening, here's what's supposed to happen, here are the steps I went through. And it takes that text and it converts it to a 768 dimension vector, which just means 768 floating point numbers like you see here. And the numbers aren't super important. You don't have to memorize them or anything. Each one roughly represents a score along a certain dimension of the meaning semantically of words that the model thinks are important. So it's kind of like a version of 20 questions, except 768 questions, and it can represent a lot of different complex concepts. So I'm going to keep scrolling here. And what we actually do is we take those numerical outputs from the model, they're called embeddings, and we turn each of them into a feature of our supervised machine learning, or what will be our supervised machine learning model training data set. So whereas before we knew who fixed the problem, the text of the problem, and where it happened, now we have these 768 numbers that encode a lot of meaning about what the bug report is. And that's all we're going to give the ML model, and we're going to see how well it does in predicting, using this text, which of the files in our code base is likely related to this bug. So kind of a complex problem. I mean, software development's not easy. Reading bug reports is not easy. Knowing where to go in a code base with multiple files, that's not straightforward either. I mean, we're not predicting if someone's happy or sad based on a tweet. This is kind of a complex domain. And if you've been watching, we didn't tell it anything about the code base. It doesn't know what JavaScript is, any of that sort of stuff. So we set up the AutoML environment just like before. We train our model, and we see a bunch of different ones performed different ways. We check out a little model. I'm going to keep scrolling here. This tells us how well things did. You can see it performed differently on different classes. Some of the files in the code base didn't have as many samples, and not coincidentally, the model doesn't perform as well on those items. This is just us showing all the predictions from the test set. What I really want to get to is at the end here, where we basically have an example of using this as a magic decoder ring. So this is kind of how our API works in a very basic way. When we're passing back the prediction, you give it a new bug report, and the model responds with, I think it's in this file. And yeah, that actually sounds reasonable. Someone's saying they had a problem logging in with their Facebook account, and it recommends you check out passport.js within the Facebook subfolder, which sounds reasonable to me, given the code base. So kind of cool that works, and you can use it for such kind of complex operations. So with that was all the things we wanted to show you. I see we've gotten a few questions while we were talking, so I'm going to stop sharing, and let's check them out. So okay, we've got a couple here. Maybe Wei and I'll alternate answering some of them. So how much does Nightingale cost? That kind of depends on what folks want to do. There is some infrastructure involved in it. as well as all of the automated deployment of it. And then we do include, you know, support for folks onboarding on the platform and getting used to how they use the platform. So depending on the number of users and how much storage and how much compute power people and how many hours a day they want it on and available and high availability, the cost can vary a little bit. Our base package runs about, I think, 25,000 a year for the starter one for a couple of users and a couple hundred gigs of data. See the way you want to take the next one about the coding knowledge.
Yeah. So the question is, do you have to know how to code to use Nightingale? The answer is no. We definitely have a dashboard that designed specifically for business analysts, data analysts, and business owners who are more comfortable with like a drag and drop user interface.
Yeah, I think it's kind of the best of both worlds. You know, some people like to code and that's powerful, but we don't want to make that a requirement. What machine learning libraries do you include? So great question. I'm sure a lot of people have heard of deep learning and you know the neural networks that go along with that. They're good for some tasks, especially like around image classification. They're kind of the only game in town in many ways, but there's way more out there. Some have been around for a long time and work really well on other domains of problems. So we actually have lots of different libraries we include. You may have seen some of them when we were showing the table of the different AutoML, the different libraries that use the AutoML. So like gradient boosted decision trees are a whole nother class of algorithms that we have in there as well. And those work well kind of with more tabular structured data. So boost like GBM from Microsoft, XGBoost is kind of another one in there. Logistic regression, random forest is from the 90s, but honestly, that's a great one to start with. It runs really quick and gets pretty good results. So we probably have 20 or 30 available between all the different libraries. Yeah, so lots of options there. Wei, do you want to take the next one about the installation?
Yeah, so the question is, what do I have to install on my computer to use Nightingale? And the answer is nothing. That you just need to have a web browser and you can access Nightingale.
Cool. Does Nightingale create vendor lock-in? I like to think no. I mean, obviously, there's a lot of pieces to Nightingale. You can't, you know, we hope the platform makes things very easy. But if you're, you know, a seasoned data scientist right now, and you were watching how we were doing all the coding, except for the Night library that we use to easily load and unload data, we're using a lot of very public libraries. So our intention is not to lock people in. It's to make it very easy to do all the stuff you want to do. But you know, philosophically, we're not going to lock your data up in any proprietary format on the back end, the data lake. We're storing stuff in Parquet files, which a lot of different tools can read, and we encourage people to access the data in the way that makes sense for them. Let's see the next one. How do existing clients use this? Wei, maybe I'll take this one and you can take the next two. So we've got a couple customers that are kind of our launch customers that are already on it, even though we just launched the platform, you know, just a couple months ago, and they're using it really a ton of different ways. The nice thing, and Wei definitely touched upon this, the platform is data agnostic. So we've got people using it from everything from identifying which programs within their organization are more effective in supporting their mission, to people optimizing their help desk, people doing image classification and text data classification, structured, unstructured. So kind of our goal is to support any kind of use case that people normally do with data tools, you know, querying them, creating models, analyzing it. We want to support that, and you can use a lot of different industries and areas. Wait, you want to take last two?
Yeah. Will CVP provide the platform, data scientists, or both? The answer is we can provide the platform, we can provide the data scientists, and we can provide both.
Yeah, whatever makes sense for the situation.
Yeah.
We've got customers who are just using the platform, and they've got data scientists who are rocking and rolling, and then we have other customers where we're kind of a full stack vertically integrated operation, where our data scientists are using Nightingale as an accelerator to deliver the insights to the customer, and they don't want to have to worry about all of the logistics of how that works.
We can certainly provide training to the data scientists as well.
Yep. And I think that last one's all you, because you were showing that earlier.
Is there a limit to how many widgets you can add to the customizable dashboard? And the answer is no. You can add as many widgets, as many charts that make sense for your organization.
Cool. Okay. Well, it looks like all the questions we had. So we definitely appreciate everyone who came today and checked it out. We'll be sending out a survey afterwards to, if you want to let us know what you thought or topics or questions that you have that maybe you didn't get to answer right now. And yeah, thanks for coming, everybody.
Yeah, thanks for watching.